Well, they weren't called dots though.
Points.
Points, yeah. A dot is what the picture is, but the term is points. Okay, so that's only the first part. That's not quite everything. So we'll go through that really quick again. Well, actually, maybe a little bit more in detail. The most basic figure in geometry is a point. Okay, but what's weird about a geometrical point? Did we talk about this probably?
It has no dimensions.
It has no size. Yeah, it has no dimensions. So you can't really draw anything with no dimensions. So we just make it a picture of a dot. A point represents a location in space, but it has no size. Okay, is there a special symbol to represent points? No, there's not. So if they say, what point is on the smartboard? Guys, I feel like you guys are going to need a assigned seating, which means we all will probably. But anyways, so if they ask what point is on the smartboard, you could just say A. Like question number one, what point's on the smartboard? The answer would be A. You don't even have to say point A. There's no symbol for a point. A implies the point A, okay? Lines. So what's special about geometric lines?
One dimension.
They are infinite in both directions. So normally when we say a line on a piece of paper, it goes from there to there. So in geometry, we're talking about the infinite line. That it's kind of like from here to here is a line on the edge of the light, but it's a part of the infinite line that runs along all these lights. So lines in geometry are infinite. How do we label lines? Usually you need 2 points. Okay, so is line AB, and is there a symbol? Yes. So to name a line, you use 2 points that are on the line and the line symbol on top. Line AB. Is line AB the same thing as line BA?
Yes.
Yes, because there's not an order to it. You're just talking about the entire infinite line. Okay, if there's another point on the line, is line AB the same thing as line AC?
Yes.
Yes, because you're talking about the infinite line that those 2 points are on. Can I call it line ABC? No. Do not use 3 letters to name a line. So do not call it line ABC. Okay, also, so any 2 letters in any order for a line doesn't matter. Sometimes, it's not that uncommon, they'll put a little lowercase letter on the corner of the line. In this case, you could just call it line N. Okay, and in that case, you wouldn't use any symbols. Alright, so you can kind of tell it's a special letter because it's lowercase, it's italicized. And these are capital letters for points. They always use capital letters. So occasionally they will do that just to make it a little easier. So they might say what line is parallel to line M, and your answer could just be N or something like that. Okay, points, lines, and what came next?
Planes.
Planes. And a plane is a 2-dimensional surface that goes forever, a flat surface that is infinite. We can't draw anything infinite, so we have to use this picture. This is called a parallelogram. We're not really learning about parallelograms yet, but that's what it is. And it just implies that it's part of the infinite plane. Okay. To label a plane, usually you need 3 letters. You guys know why we don't use 2 letters? Anybody want to guess?
Perception lines.
Right. If I just say plane X, well, this is kind of tomorrow's lesson. There can be a lot of planes going through point X, so you don't want to just call it X. If I say plane XY, could there be multiple planes that contain points X and Y? Yeah, like cutting right through here, right? Or it could be coming at this angle. Yeah, there's multiple planes that could contain X and Y. But if I say XYZ and XYZ are not in a line,
There's only one plane.
there's only one plane that could describe that. So that's why they make you use 3 letters. Same thing, that's why you use 2 letters in lines, because through any 2 points, how many lines could go through that? Only one. Okay, it can't look like that, right? That's not a line. But plane has 3, so plane XYZ. Does the order of the letters matter? No. It doesn't have to be alphabetical. Also, sometimes, just like lines, sometimes they'll put a little letter in the corner, italicized. So you could just say it's plain K. If they do that. It's lowercase, italicized, sometimes. Okay. Now, special drawings. Let's see if I can. Go this way. All right. What image do you guys see there? Yeah, it's kind of a book. I was kind of going for like a laptop looking thing. But this is 2 different planes that are intersecting. You guys see that? If I draw it neat. Nope, not neat enough.
Double laptop.
Good.
What is that, Mr.
Okay, I didn't draw this one well enough.
No, I never mind.
Okay, these 2 should look the same. That's why these 2 should look the same. Yeah, it's not working. All right, I'm gonna give up on that. We'll come back to that next time. Yeah, it's supposed to, look more like a fan windmill shape, yes. I was having trouble with this one down here. Okay, anyway, you guys see the shape?
Mm-hmm.
It helps if my lines are all like identical looking, but I kind of failed that. Yeah, it's supposed to look kind of like a propeller-ish. So there's a plane that's kind of horizontal going this way, and then there's a plane vertically going this way. And they intersect, you see where their 2 planes are intersecting at?
Mm-hmm.
Along this line right there. Okay, why is there a dotted line right here, right there?
Shows where the line is through the other planes.
Right, the dotted line implies that's a line in the background that's behind something else. So this plane that's like horizontal is on top of this line that's going through the back there. Same thing with this one right there. Did I draw the box on Thursday? I can't remember if I drew one of these.
I think you did.
So on a box, the dotted lines would look like this. Whoops. Right, so you got the front edges. Those 3 edges in the back would be invisible if it was a normal box. So they're dotted. Got it? Anyways, I can make it neater, but all right. So if I draw a point here, you could say, let's call this plane P. Okay, if I drew a point here, you could say point A is in plane P, or is contained by plane P, or is on plane P. Does that make sense? So you could say it's in, on, or contained by plane P. Okay, it is not on, it's not in, it's not contained by plane M. Okay? So here's a line, call it line N. So line N is in, on, or contained by plane P. Okay, now here's where it gets a little tricky. We can get rid of that for a second. What's happening with this line? Just draw straight. What do you think's supposed to be happening with this line? We'll call it line L, cursive L.
Going through.
It's going through. So let's call that plane, or point A again. So you could say line L is intersecting plane P. So intersecting is the technical term, at point A. Line L is intersecting plane P at point A. You guys got that? Okay. You could have, so a line can intersect at a plane, two lines can intersect each other. Okay. So intersect is kind of a technical term there. In, on, contained by, and intersecting. It's possible also that lines and planes would never touch. So when would, what's it called when two lines never touch? Parallel. Okay, now technically it's not just called parallel, or it's not just that they never touch. Parallel lines not only never touch, but they're also always in the same plane. So, like my arms are right now, they are parallel, right? Now, if they look more like this, are they parallel? No. Are they going to touch? No. No, because this one's floating up here. We're in 3 dimensions now. On a 2-dimensional surface, that's in the same plane. So these lines are parallel because they're on the same flat surface. But if I have, like this arm is one line and this is another line, they're not parallel, but they're not touching. This is called skew. So they're not in the same plane. They're not on the same flat surface. Skew lines never touch, but they're not in the same plane. So you can have 2 lines that are parallel in the same plane. If I drew another line like this, it would be intersecting the plane, and it does not touch those 2 lines. So this line would be skew to these 2 lines. You could also have 2 planes that never intersect, and those would be called parallel planes. It's kind of like the floor and the ceiling are parallel. Yeah, I don't think you guys are quite ready to sit wherever you want to yet. So floor and ceiling are parallel because they would never touch, opposite walls. Those would be parallel planes. All right. Do. All right, let's do this worksheet here. This is pretty easy, I'd say, in my estimation. Although your guys' grades on the, you guys' grades on that last paper pretty good. Maybe I should help you with the arguments. Give you more of a challenge.
What's the notebook? Yay.
This is the only worksheet we're doing this week, so don't think you don't need to bring your book with. Although I do use more worksheets in this class than I do in algebra. Whenever I don't like the book, I basically do a worksheet.
So you didn't want to present it?
It was okay. I wavered. I'm still not sure. Maybe I should have. Okay. So 1 and 2 are kind of the weird questions. Number 1 says the distance from U to S. So it says estimate to compare the values. So they're trying to get you to use your 3D imagination. So what do you think we know about the distance from U to S to U, and U to T? They're supposed to be the same. They don't, if you like got a ruler out and measured them, they're not actually, oh no, sorry, that's wrong. That's wrong. They're not the same, my bad. I didn't look very carefully. Okay, which, that square on the left or the rectangle thing on the right, which one is longer? The right one. Okay, it doesn't look much longer because it's supposed to be a 3D image. They didn't make that clear though, did they? Maybe they did mean it was a 2D image.
I can kind of see it if you go forward, so.
I see it in 3D.
You see it in 2D?
Let's see. Well, I almost
I
see
just
it.
see numbers.
It's kind of, in 3D, it's kind of like a book that is open towards you. You see it?
Okay.
It's like a folder that's open towards you. You see it? Like this is the right page of the folder opened out this way, and the left page is open this way. If it was a 3D image, I'm gonna just, 1 and 2, you're kind of gonna get a freebie on these two because they're not really a part of the rest of it. If it was a 3D image, the right side would be bigger. So I'd say UT is longer. If it's a 2D image, I think they're the same. So if it was a 3D image, I think UT would be longer because it's a longer rectangle, and the left one is a square. I don't care. I don't care about number 1. Yeah, it's too vague. The question's too vague.
1 and 2 or just 1?
We'll go ahead and answer 2. There's only one right answer to number 2, so we'll go ahead and put it.
So just put UT as bigger.
That's fine. On number 2, it says which shape is bigger, the left one or the right one. This one, we're going to spend a chapter on areas like 3 months from now. We're not really doing it this chapter, but which one do you think is bigger or the same?
Are they the same?
They are actually the same size, same area. Here, let me show you guys a trick that kind of proves that point.
You just like shift the bottom to the right.
Yeah, exactly. On a parallelogram, so the bottoms are supposed to be the same length. Okay, imagine I took some scissors and cut this off and then moved it over here. Okay, how long would this be right here? Well, the same as that, the same as that. How tall would it be right here? The same. You see that? So a rectangle with the same dimensions as a parallelogram is the same size. So if this is 6 and this is 7, and this is 6 and this is 7, they're the same exact size. Because if you pick this up and put it over here, it's still a 6 by 7 rectangle. Anyway, that's more of chapters 7-ish thing. But okay, number 3. This is getting to what we were actually talking about. Okay. Oh no, I did the wrong one. Okay, that's fine. I meant to do a different page. This one will work okay though. Okay, number 3, true or false? AB, line AB is in plane M. Okay, you gotta look at that picture on the right. Do you guys see plane M?
Yeah. Yeah.
It's the vertical plane, the up and down plane. Is line AB in plane M?
Yes.
Yes, it is true. Okay, number 5. It says line AB intersects in at E. False. Line AB is in plane in. You probably wouldn't say it intersects anywhere because it intersects at a lot of places. So you would not say line AB intersects plane in anywhere because it's in plane in. Okay, then it says F, where if you look at the picture, F is a point. F is in plane in.
False.
False. All right, now there's 2 words that I forgot about. One of them is collinear. Do we have 2 ends on that one? No. I always forget if it's 2 ends or 1. And coplanar. 3 points could be collinear if. Anybody think they might know what collinear means? Points can be collinear on the same line. So collinear points are points that are on the same line. Any 2 points can be collinear, right? Any 2 points can have a line between them. But 3 points are not necessarily collinear. They might not be on the same line. But if they are on the same line, they're called collinear. Okay, also our book uses the term non-collinear. So if points are not in a line, then they are non-collinear. Co means with, linear means line, it's adjective form for line. So what do you think coplanar means?
Not
Coplanar means points that are on the same plane. So in the picture they would just look something like this, but coplanar points are on the same plane. So non-coplanar points means not on the same plane. So in the picture they might look like this, like somebody's off here by himself. It's kind of hard to draw 3D images in 2D, but this picture kind of represents 2 points on a plane, third point not on the plane. All right, back to it. So, given that information, are points A, D, and F coplanar? Okay, they're not on the horizontal plane, but they are all on the vertical plane, the up and down plane. So yes, or true, I guess.
Wait, I got a question.
Yep.
If there's, I don't know if you already explained this or not, but if they're in 2 planes, if the letters in 2 planes, does that mean they're both? They can be in both?
Yep, it can be you can have infinite planes going through. Like, if my arm is a line, I could have a plane coming like this, like this, like this, like this, like all different angles. Planes don't have any width either, so they can fit infinitely. All right, so yeah, a point can be in multiple planes. A line can be in multiple planes. Number 11, E is on line CD. Is that true? Yeah, line CD is E is on line CD. Do you guys see line CD? Cutting across kind of diagonally across the horizontal plane, and E is also on that line. Yep. Okay, 13. So 13 has a box picture. We'll learn a more technical term for this later. Have you guys heard of a prism, rectangular prism? That's the technical term for the box shape. How many sides does a box have? No, 6. Or a cube or a box or 6. So each of those 6 sides is a plane, right? Or it's part of a bigger plane, you could say. So a box has 6 planes on it also. So the question on 13 through 16, name a 4th point in the plane, in the same plane as the points given. So on 13, what plane is ABF? Which side of the box is ABF on? Top. The top plane. So what's the 4th point on the top plane that they didn't list? E. ABF, E. So 13 is just E. Okay, you could name the top plane ABF or AFE, or any 3 points on that top plane would be the name of it. 15, which side is plane CGE?
E is in a different plane.
Okay, trick question. Yeah, they are all in a plane, however, the plane is not pictured. They kind of caught me off guard there.
Is that H?
Use your imagination. A. Nah, it's not in there. I wish I had like a giant clear box that I could do it in. Do I have a giant clear box? A 3D box, I mean, like a real box. I think this is an error, because I don't think there is another point.
Was it number 16 just like it? I did it again.
Yeah, 16 is just like it.
EBC. No, EBC does have an A and C.
H.
So 15 has no answer?
15 is 15 would be A.
Oh, no. Yeah, you guys are right. Sorry. I was looking at the wrong thing. Yeah. 15 is CGE. So CG, it's kind of hard to do this 2D. CG is on the front corner, and E is in the back. So it would kind of be a plane that's like ramping up towards the back, like this. So it would hit these 2 corners and these 2 corners, like going front to back, diagonal plane. So for those of you who said A for 15, you were correct. So yeah, that plane is not pictured, but it still exists, all right? So that happens sometimes in these problems. 17, what are the name of 3 lines that intersect at point E? Yeah. So technically you could name a line that's not pictured like GE, but if we can, let's stick with what's in the picture. So they said line AE, FE, and HE. Notice they all have E in their name, right? So how would we label that though? Well, you just say AE and then put the line symbol on top. The symbol does matter because later on we're going to be doing line segments and rays, and they have different symbols. And half lines, they have different symbols. So AE, HE, and FE. All right. 19. What are 2 planes that intersect in line CG? Okay. Why can't we just call it plane EC? How many letters do we need to describe a plane? 3 letters. Now, in the picture, all those planes have 4 letters on them, but we need 3 letters to name it. So let's start with this. What is one plane that has line CG in it?
CGFB.
Okay, CGFB. I'm just gonna call it CGF. It's okay on the planes if you use 4 letters, I guess, but let's call it plain CGF. CGF is the plane that's facing towards us, the part of the box that's closest to us. But plain CGF. Okay, that's the front plane. Which other plane has line CG in it? DCGH or DCG or DGC. The order doesn't really matter on that one. CGH is the bottom plane. That would be the same as DGC. The order of the letters doesn't really matter.
Wait, so why do they use 4 letters on 18 for describing a plane?
You can, but normally it's just list at least 3 that aren't in the line. But I did say you could use 4. They never do that on lines. They never use more than 2 letters on lines. But on planes, sometimes they do use 4 letters, especially if it's in a box shape. But as long as you have 3 letters, like there's only one plane that DC and G are on. There's only one plane that has that name. So that's why you have to use 3 at least, but 4 is okay. Okay, sketch. Vertical planes P and Q intersecting in line RS. What's vertical mean? Banana. Well, they can't both be completely vertical or else they would be parallel. So we got to make sure they intersect. Okay, start with a parallelogram. Okay, these 2 lines should be going the same length and direction, and these 2 lines should go the same length and direction. I'm going to make kind of an X, a plain X thing, kind of like this is what I'm going for, but overlapping. So 2 vertical planes, kind of like the picture on the second section, but more vertical, I guess. Okay. Let me test this out first. Oh, yeah, that makes sense. Okay. I can't draw a straight line all over. All right. Okay, let's start at the beginning. So I started by drawing a line that's like through this plane, like kind of straight up and down, basically. That is the line that's going to, is where my other plane's going to cut through there. Okay, we need to match this line kind of, the closer it looks, the better it's gonna, the final one's gonna look. This line that intersects through this plane should like match this line. That's gonna be the edge of my plane. And then I'm just gonna like connect those. Okay. Now, if I do it like that, that means this plane's in the back, so it should be dotted. And then you're supposed to keep going through on the straight. That's where I keep getting it wrong. Right? Just having trouble drawing straight lines. This one would be dotted. This look the same. Maybe it should have stopped right here. Okay, 22 is a lot easier because it's just one plane. If you want to, even though it's not quite what they described on 21, if you're having trouble, you can kind of recreate that picture they made on the second section.
Relabel it.
Oh yeah, they did say label. Planes P and Q intersecting at line RS. So I'll just put an RS right there. Oh shoot, that was quick. All right, it's due tomorrow.
Time to go.
Yeah. 5th hour is a little bit